Microsoft Azure offers Azure Kubernetes Service, which lets you deploy and manage containerized applications more easily with a fully managed Kubernetes service. In this video, we will be covering creating Kubernetes cluster, managing resource group, and deploying Kubernetes cluster, communicating with Kubernetes cluster using Cloud Shell, hosting an application on Kubernetes cluster, and running applications on Kubernetes cluster. In the end, we will also share details about a free Azure Administrator Masterclass, which will not only help you understand basics, but it will also give you an idea of the learning path to follow. It would be helpful, especially when you're preparing for Azure Administrator Certification, which requires you to clear the Microsoft Azure Administrator Certification exam. That's AZ-104. For the certification exam, you should have an understanding of Azure Kubernetes Cluster. Welcome to another episode of Azure video series from K21Academy, where we take you from complete beginner, covering networking, storage, data protection, to all the way monitoring, governance, and compliance, including how to prepare for the AZ-104 certification exam. We have taken a clip from one of our certification training program on Azure Admin. That's AZ-104. And in this clip, our instructor will talk about Azure Kubernetes Cluster. So, this is a clip taken from a module on serverless computing. Now, let's hear from an expert trainer on the same.
So, to pick this pattern, first thing you should have activated a free trial account. And once you do that, you can access the Azure platform with a URL which is portal.azure.com. So that's the URL you will require in case you want to access the Azure platform, and this is the one. Now let's go, without wasting any time, deploy the Azure Kubernetes cluster. To create that, you can go to this create a resource menu and you can choose a category in here, and the category is called compute. So Kubernetes is a part of the compute category in which you can find the service Kubernetes Service. Now this one, as I mentioned, you can deploy it in a simplified way, or you can go in depth in understanding all the concepts in it. So going with that, so subscription, as I mentioned, when you people do this, you will get this as free trial account. For me, it's the sole following one. Next one is a resource group. That's a kind of folder you can imagine, a logical entity in which all your resources of Kubernetes will be maintained. So you can choose create new option. I will name it as AKS_RG. So Azure Kubernetes resource group, I name it and I click OK. So in the folder, my cluster will appear. Now cluster name, let's say my cube cluster, I'll name it. So that could be my name of the Kubernetes cluster. And your Kubernetes cluster, you have to specify in which country you deploy it, since it's a cloud platform. These are all the various countries you have in which you can deploy it. Say, I'll pick my data center as East US, which means in the East US, I will be having my virtual machines of the Kubernetes cluster, including the Kubernetes. Now, availability is very important. So as an administrator, you will deal with this, which will give you the high availability, that is guaranteeing the availability of your VMs, where any short circuit that happens in an Azure data center or any planned maintenance you do will not affect your servers. For that, you can deploy your VMs in 3 physical data centers, which means you distribute your VMs into 3 physical data centers that will be available in this East US region. So that's what the zone 1, zone 2, and zone 3. In case I select only one zone, which is only one data center will be selected in East US region, and all the VMs from 1 to 1000 which you create, you will keep them in one place, which is not a best practice. So going with multiple zones like this, you are getting 2 or 3 physical data centers in which your VMs will be replicated, or in other words, deployed. So you get a redundancy, which is a very important factor for high availability. Same way, there is a Kubernetes service, right? So that is a technology, and there are various versions in it. Each version will define the changes, the facilities they offer. At the end of the day, it's all about their performance and offerings. Current version is the default one, which is 1.19.9 will go with. There is not going to be a big difference in terms of factors, but their internal working and performance will vary because of these. Currently, this is fine with default version. Now see this, whenever you create a Kubernetes cluster, the first and foremost component, that is the primary node pool, which are all the VMs that will be controlled by your cluster. So this primary node pool, you can select it, and this is going to be always the Linux node pool. When you say node pool, this is nothing but one VM or 100 VMs or 1000 VMs in a group. Maximum you can have 1000. That's a pool. So here you can select a size by clicking change size, which is your virtual machine size. That's your node. So you can select between any of these, but remember, once the size is selected and your nodes are created, you cannot resize them. I meant that you cannot change the size after this is created. So best practice is to select them in a right way. Now node count indicates that how many VMs you're going to have in the cluster. From 1 to maximum of 1000 VMs you can have, which is a limit. That is the limit for one single Kubernetes cluster. So for a best practice, minimum of 3 you should have to get high availability, which means each VM will be available in each data center in the zone 1, zone 2, and zone 3. If suppose you go with one VM, still it's fine for testing and development, but for a production, that's not a best practice. Let's say I'll give 2 instances, which is also good, but not that a best practice. But just for testing purpose, I'll mention 2 VMs I require, which means I get each VM with 2 CPU cores and 7 GB RAM and couple of machines like that you will be getting. And both will be Linux VMs because the primary node pool is always a Linux node. Now I go to next menu, that's your node pool. So this is the primary pool which you cannot delete, and you can only see this. Followed by that, it's always with Linux machines. So in a pool, which is group of VMs, you can only have one flavor of machines, which could be either Linux or either Windows. And just mentioning, you cannot run a Windows container application on a Linux server, which means if you want to run Linux container applications in Kubernetes, you can click this add node pool. And I mean, if you want to run Windows container applications in here, you need to add an additional node pool that could be of Windows, and you can mention how many servers you will require, and you can create them. So followed by that, you cannot have 1000 because you already took 2 for previous pool. So you can only have 998, it says. So until these numbers you can have, and these complete machines in this pool will be Windows. So in a pool, either Windows or either Linux. Enabling virtual nodes, as I mentioned, I was mentioning a concept, that is, you cannot change the size of your VMs once after that is created, which means you have 2 CPU cores and 7 GB RAM, and once your cluster is created, you cannot change the size I mentioned. In that context, what happens in here, suppose you deploy 1000 VMs, and now all 1000 VMs with their all CPU core and RAM is consumed, and I need more resources. That's where you can enable this option, which is enable virtual nodes. So if you tick this, you can enable virtual nodes, which means in the networking menu in here, a subnet called virtual node subnet will appear, where you can attach a service called Azure Container Instance to get more capacity that would give you higher level scalability. You will understand it if you know a service which is called Azure Container Instance. But this is all about getting more resources to the Kubernetes if you lack the CPU core and RAM because of the limitations. And this other one is to specify like your virtual machine scale sets are being used in the cluster. And apart from that, in the authentication, if you see, it is either a service principal or a managed identity, which is nothing but an identity that gets created in the Azure Active Directory, which is responsible for letting your Kubernetes cluster to manage your Azure VMs. So this one will go default. And other things, if you see, the RBAC, you have the role-based access control. So in the role-based access control, if it is enabled, you get particular roles of Kubernetes service that you can use in Azure Active Directory to provide fine-grained access to the users for Kubernetes service in your organization. Followed by that, if you want to have Active Directory groups created, you can enable this, and you can add groups in your Active Directory from here, which could help you to include members of your Kubernetes usage with the role-based access control with Active Directory groups. So for now, I'll not enable it, but just mentioning these are some choices. Now for compliance, you can encrypt the operating system disk of every VM that gets attached to the Kubernetes cluster, and that is either encrypted with Azure offered key. If not, you can go with your own key and encrypt, which are two different choices. So currently we'll go with this. Now in the networking, you can see there are two types of networking plugins. One is KubeNet plugin. In situations where you don't want to manage the virtual network of the cluster, I wish that Azure can manage it, we can go for KubeNet plugin. But in situations where I wish that I want to manage the virtual networking because I have a custom requirement to set up firewalls, VPNs, or express route circuits and etc. for a hybrid data center, you will go for Azure CNI or Container Network Interface plugin, which will let you to manage the virtual network of the cluster. For time being, we use KubeNet plugin, so no configuration has to be done for networking. Now this DNS prefix, it's not accepted because I gave the Kubernetes cluster name as my kube cluster with underscores in the name. So let me change it. Let's say my cube cluster. So this will be a DNS, which means my cube cluster with some random value gets added in the suffix. That's a DNS for accessing the cluster. Meanwhile, your Kubernetes cluster will communicate with your VMs via load balancer. So on standard load balancer getting created here, and enable HTTP application routing. If you tick this, you're allowing HTTP access to your containers in the cluster. For testing and development, this is fine, but for production, it's not a best practice to enable it. In fact, any API calls that you use or make a request to communicate in your cluster, and this option is disabled, then the connections will fail if there is not a HTTPS connection. Along with that, enable private cluster is an option that could help you to enable this as a private cluster, which means you can use it for internal usage in the internal network. Followed by this, I'm disabling it. This is a firewall setup. If you want to set authorized IPs, where only certain range of IP addresses should be allowed to make a connection to your cluster master, you can set this. It could be like a firewall option to allow only your on-premises IP address of your organization or your organization IP address of a particular server, you can use this. A network policy, if you see, default is none, which means interaction between containers running inside the cluster will be allowed by default. But you have some couple of policies. One is Calicio, there is Calico, a policy that is from open source platform, which could help you to define interactions between containers, like blocking their public access or allowing their public access and all these. So coming back in here, in case you go for Azure Container Network Interface plugin, see Azure is supporting for their policy, and both are networking policies where they have some predefined configurations written where you can use them after you deploy a container, so you can control the cross communication or public interaction for a container in your cluster. Currently, I go for KubeNet and go for none, the default one, which is fine for now. And the last one, that's your integrations. So if you wish, there is a service called Azure Container Registry, which is a repository for maintaining the container images that a developer develops. So you can store those images in this, and if you want to integrate this directly with Kubernetes, you can select it. So Kubernetes can pull the image directly from the container registry. So regardless whether you're using Azure's or anything, but the architecture of Dockers and containers is a container application might be maintained in a repo if you want to deploy it. For now, I don't have one, so I'll leave it. Apart from that, for monitoring your cluster for diagnosis, you have a service called Log Analytics Workspace. If you enable a service called Log Analytics Workspace will get created, which is a diagnosis and monitoring option for understanding the performance of your containers and servers that are used in the cluster. For now, I will disable since we are not going for monitoring. And finally, one of the services in Azure that's called Azure Policy, so which is one of the administrative component, which is for enforcing compliance and security in your organization. If you enable this, there are some group of policies given by Microsoft. Those group of policies, Azure will be enforcing over your Kubernetes cluster to make sure that server scaling, security, and compliance will be maintained. So currently, I don't want this. Later as well, you can enforce them. We'll keep it disabled. And the last one is tagging, which is a logical grouping option. Suppose thousands of resources you create in Azure. Now you want to track their billing. So billing you can track from here. That is where you create a tag and a value. So that would be used for logically grouping your resources in the cloud platform. I'm skipping this for now, but this is one of the logical grouping for billing and all the activities of grouping. We go for review plus create the last page. Now you can see All the settings we made now, they are consolidated at once, and in the background a JavaScript object notation is being generated. So this will now let you to go and deploy an ARM template which will make a REST API call to Azure platform. So that's it. Once your validation is passed, you click this. So what happens now, I just click the create button. So what happens in here is, in the background, the Azure is making a REST API call to the Azure endpoints, which are on behalf of you deploying virtual machines, and then Kubernetes cluster, load balancer, and all the security policies in the Azure data center in the East US region for you. Which means now, if you just go to this menu, the burger menu in the top left corner, and if you go to this service which is called resource groups, you can see this is a resource group you call, which is a folder, and AKS underscore RG is the name we gave, inside which your Kubernetes cluster is getting created. So here it is. So my kube cluster, and it is still under creation, which means you can see the status. Meanwhile, the other one is empty resource group. This is for monitoring option, which we disabled. But the third one, you can say MC, AKS, and some random name. This one is holding all your components, which includes these, like a Kubernetes cluster, which is managing a virtual machine. That's called virtual machine scale sets. Our network, the IP address, the load balancer, the identity for management, the routes, the security rules using network security group. All these are created by the cluster, and the best thing, you can even let the cluster to manage your VMs as well. That is also supported option which you have for virtual machine scale sets. And this is nothing but VM, but not one VM, but it's like group of identical VMs that can get created from 1 to 1000 on demand, and they can get removed when there is no demand as this feature. The reality is, your containers that you will run will get hosted inside these virtual machines, which are instances in the left side. But the only thing, I don't control these VMs in terms of hosting the container. For me, Kubernetes is reducing the burden, where it is taking the blame of putting my containers out in there, managing them, and getting all the instructions from me, but complete management and scaling, everything is done by cluster. And to access this, follow these, go to the menu, resource groups in the left side, go to this AKS underscore RG, and here is your cluster, which is under creation. Now, for this cluster, there are many ways using which you can deploy containers, connect, and interact. So one of the simplified and easiest way that Azure offers you is this term. You can call this as Cloud Shell. So if you click this one, you get access to something called Cloud Shell, which is a place where you can go and run commands. So for the first time, if you're opening it, it will ask you to select between two options, Bash or PowerShell. You can click an option called Bash in here, which is not showing for me because this is not my first time I'm opening this. So you can click on Bash, then you can click this Create Storage, which will now create a component called Cloud Shell, which is a cloud-based environment that will help you to run command line interface commands, which can help you to communicate with your Kubernetes cluster, interact, and do all the activities. Meanwhile, the bell icon shows me the deployment is successful and my Kubernetes cluster is successfully created. Now my target is, I'm going to connect to this cluster through Bash, and I will host a sample application which we have in Docker Hub and will integrate for interaction. Now for getting this done, I have a pre-written piece of scripts with me. Let me use them. So to deal with, so I'll be accessing something. Okay, so to deal with, I have a script with me. So this is an YAML script, and this is nothing but a script in which I'm defining my container which I want to host, how it should look like, and everything we have pre-written in this with instructions. I will explain it, but before that, let me connect to my Kubernetes cluster in this Bash environment. To do so, I will use this connect button in here. Now, this shows me instructions to connect. So AZ account set is a command to select your Azure subscription, and in my case, I already logged into this Cloud Shell with the same subscription of Azure. So running this command or not running this command, it's not going to make any big difference. It's still the same. But the second command, AKS get credentials, this will help you to connect to your Kubernetes cluster, where you can mention the resource group name in which this cluster is and the cluster name, which is this one. So I click this, I paste this command in here, and now this will create a connection to the Kubernetes cluster, which is stored in this configuration file in this Cloud Shell. Now, what is the benefit? From now, I can use a command which is kubectl command line. Let's say if I use a command like get nodes, kubectl get nodes, it will get all the virtual machines that were created when the cluster was created. Currently, I created 2 VMs when the cluster configuration was done. So 2 VMs you can see which are shown. Suppose I write a command kubectl get pods. So when you write this command, it's checking for containers and there are no containers hosted at this point. So it says no namespace found. Now what I will do, I will create a file now. So the file name, I'm going to name it as azure-vote.yaml. So the code is, what is this code indicating? This is simple. When you use this keyword, which is CODE, it will open the Visual Studio Code editor in the Cloud Shell and a file named azure-vote.yaml. .yaml is the extension that we will use in this environment to define your container configuration in the cluster. Now I just run this command and you can see the Visual Studio Code editor, you can call it, this got opened and the file named azure-vote.yaml is created in it. Now what do I do? This given script in here, without any additional spaces, I just copy this one until the last line of the script without any additional space or tab button. I copy this and I paste it here. So there is no paste option, so you can use Control V and you can paste it. Now see, this is a complete YAML script. Very quickly I'll explain it, try to understand. So this API version, app/version1, where you're indicating the version 1 of this application, and this is a part of syntax. And the kind you're mentioning that you're doing a deployment, and the name of the deployment we are mentioning azure-vote-back, and the specifications in this block you're mentioning replica is equal to 1, which means you're creating one replica of your container application. And again, these are again syntax of this in which you mention that your app name as azure-vote-back and template or metadata labels or additional info you can provide, which we are giving blank for now. See the specification block. This is where node selector is mentioned, which is mentioned as beta.kubernetes.io/os as Linux, which means it will go and select the Linux clusters for you. So currently we have only Linux pool, so it will select the Linux VM to host your container. Now there comes your container in details you're giving. So you're saying containers, name of the container as azure-vote-back. Now, image is the one in which you deploy or define your container application detail. So here we're mentioning the image name as Reddish, which is nothing but in this following website, which is Docker Hub. This is the Docker Hub, which is an open source place where you can find container images. Suppose you search for Redis in here. Here it is. Reddish is an image which you can find in here. This image is the one we are mentioning in my YAML file. So this is a cache database that can store the data and cache inside it. So that image is what I mentioned in here. So this image will be pulled in this given scripting where the Reddish image will be pulled and the resources we are mentioning for this, where it can have 100 memory units of CPU core, which is like 10% of a CPU core, and 128 megabits of RAM we are mentioning. The limits is like scaling. Suppose if this is not enough, you can increase your capacity up to 25% of a CPU core and 256 MB of RAM we are mentioning. Now ports, we are mentioning to open container port, which is internal port, which is within the container, within the network, which is 6379, and the name of the service we are mentioning as Reddish. Now, this is a completion of a block which you indicate with this 3 lines in here, 3 hyphens. Next, the next block of code starts where again a syntax of API version of 1 you're mentioning, kind as service, and metadata as azure-vote-back, in which note this difference. First time when you did it was a deployment where you deployed a database. Second time you do it, you're deploying a service where you're making this DB as a service. The DB service name is Azure-OAuth-back. You're mentioning it in here where the port 6379 you're exposing in here, and you're mentioning this is the app to which the internal port 6379 is being exposed. So you made your deployment as a service, so the DB service is ready. Now the next one, this is line 41. So API version, again, you repeat the same syntax. So one more deployment you're doing in the same YAML, where you're mentioning your front-end application name as Azure-OAuth-front, which is a front-end application. Now specifications, replicas you mentioned as 2, which means 2 container applications you are creating for the front-end application, which means 2 instances, or we can say 2 replications of that application. Here, if you want to have multiple, you can mention the number. For DB, I kept 1 replica, but for this one, I'm keeping 2, which means front end will be 2 replications, 2 copies of the same application. Now, your syntax, again, it repeats, which is same syntax. You see the specification block. Here, again, you're mentioning this is a Linux image which you're pulling from the environment. So you can use Linux machines for hosting the container you're mentioning. Now, containers, you're mentioning the name Azure-OAuth-front. And the image you're looking is, look for Microsoft/Azure-OAuth-front in the Docker hub we are mentioning. So check it out. If you search for this Microsoft/Azure-OAuth-front, see you have image which is Microsoft/Azure-OAuth-front, which I'm pulling from Docker hub now. So from here, the image is being pulled, and this image is a front-end image which is given by Microsoft itself for outing, which you can do you can cast your oats and etc. So that one you are pulling. Again, you're providing the resources and everything, and this time we are exposing port 80 as this is a web application. Now, main thing, the integration part. So the written image in here, this was developed in a way such that it has an environmental variable named Reddish that connects to the database. So in this deployment, here we mentioned this particular block in here, mentioning your particular service name as Redis, which is opened with port 6379. Now, you are indicating the same in here as environmental variable name as Reddish, and the value will be Azure-OAuth-back, which is pointing to this Azure-OAuth-back, which is an image or a container DB that you created in the previous step. So this integrates the front-end application with the back-end DB. Now I have to expose the front-end application to internet. That's your line 73. That another block comes where you're creating a service, and the service, the particular service detail you're passing, and type you're mentioning this time as load balancer. So previously here the type was mentioned as nothing, which is internally utilized, but here you're exposing this via load balancer. So Azure load balancer is now used to expose this container through port 80, and the image name is this one, which is Azure-OAuth-front we are mentioning. So this one will now expose your container application to internet through load balancer, where you don't need to configure load balancer and write rules. It is automated now. So without adding any additional spaces, just use the menu here, hit the save button, and this saved your file. Now let's close that by using this option, close editor. Well, the last thing, so my YAML file, I need to apply this YAML configuration to my cluster. So we use the command kubectl apply, and I gave my appropriate file name. And once it was completed, see my service and my deployment, 4 of them are done. And when I use the command kubectl get service, I got 3 services. One is my outing application, which is backend. Another one is front, and another one is my Kubernetes. Now here, the backend doesn't have external IP because I didn't expose to internet, but front end has a public IP, which is this one. Well, my front end, I made multiple replicas of them. So you can see a couple of front end pods you have, which are 2 front end web applications. One is my backend Reddish cache database, where 2 front ends are connected to same DB. Now, as I mentioned, I copy this IP address and I browse for this IP in my browser, and the load balancer's IP it is, which is now taking my request to those images, which is my front end. Now I can cast my outing with them, where my cache database is registering the outing whichever I make, and it's a cache DB, which means you can lose the data when you want to reset this. Now I say I make a refresh of the page. So I make a refresh. It works because it's a cache DB which is caching everything, but it's not a permanent storage. And in fact, DB is one replica, but my front end, there are multiple replicas where whenever I make a request, load balancer is routing my traffic to one or the other one. And that's a simplified example of an application you can run in the cluster.
So, that was a clip taken from one of the modules of our step-by-step training program on Azure Administrator Certification. That's AZ104. I would like to invite you for a free masterclass on how to kickstart your journey as Azure Administrator, right from learning basics like cloud concepts, networking, storage, and getting certified by using our step-by-step 12-week roadmap to go from complete beginner to a certified Azure Administrator. If you're interested, register for a free class by going on to K21Academy.com/AZ10410. I highly recommend you to go through this free class to see what to expect in the exam, learn basics about Azure Administrator certification, and to get a demo on deploying web servers. So, K21Academy.com/AZ10410. Please click on the subscribe button so you don't miss out on our future videos. I will see you in another episode of Azure video series from K21 Academy. Till then, take care.